In this video, we will look at how geometric entities can be provided as an input to a global function. In the previous example, the parameters to the global functions consisted of two coordinates. The parameters did not include geometric entities. However, often functions need to be created where geometric entities can be provided as inputs. In this next example, the input is a polygon and the output is a set of triangle polygons, creating a pyramid shape. As with the last example, the global function script is imported into the main script. However, in this case, polygons from the main flowchart need to be passed into the global function. The global function will then generate the pyramid. When we look at the global function start node, we see that there are two parameters. The first parameter is the input polygons. The second parameter is the height of the pyramid. The first parameter requires a single polygon or a list of polygons. In the parameter settings, there is a checkbox that needs to be ticked, called Input Entities for Global Function. Ticking this box ensures that Mobius interprets these inputs to be IDs of geometric entities. These polygons IDs will be passed in by the main script. Here we can again see the relationship between the two flowcharts. In the code for the main script, we can see that there is a loop that generates a series of regular polygons on the xy plane. Each of these polygons is then passed into the global function as an input parameter. The second parameter for the global function is the height. In this case, it is a random integer between 3 and 15. The global function behaves in a way that is similar to other functions. Existing geometric entities can be passed in, and new geometric entities can be returned. So far, we have never had an input parameter to a flowchart that required a geometric entity. This is because we have always executed flowcharts in isolation. With global functions, we now have input parameters that requires geometric entities from that main script. However, this poses a problem for the development process. How can we work on this script if there are no input entities to process? In such a case, we can generate some test data in the start node. In the start node, there is the main procedure section that is hidden by default. If this is opened, code can be inserted to generate test data. The parameter value can then be set to a variable that contains the test data. In the example code, a number of polygons are generated as test data. These polygons are then used to set the value of the first script parameter. Without this test data, it would be impossible to execute the flowchart. The test data allows you to develop and debug the script. Note that the procedure in the start node can write to script parameters. For all other procedures, script parameters are read-only. The procedure in the start node is different from other procedures. It has three special behaviors. First, it is executed before the script parameter values are set. Second, it has the ability to write to script parameters. Third, when called as a global function, this procedure is not executed. When the global function is imported into another script, the procedure in the start node will not be executed. This means that any test data that was created in that global function will simply be ignored. The geometric entities passed into the global function will override the test data.